Hello friend, today we are here on the topic coupling, design of coupling. Coupling, whenever we are using the two different shaft for the power transmission from one place to another place, we are using the coupling. Now dear, before moving on the coupling, please go for the different types of coupling. We are using two different types of coupling, rigid coupling and flexible coupling. Rigid coupling are that coupling which are used when the both shaft having the same alignment. If the shaft having the different alignment, like if I have the same alignment, then it is not a rigid coupling. If we have the different alignment, this shaft and this shaft axis is going to be differ, they are not coming in the same line of action, then it known as flexible. So rigid coupling are those coupling which are having the same line of action. It's basically of three types: muff coupling, split muff coupling, and flange coupling. And if you're talking about the flexible coupling, it's having a two different types: universal coupling and Oldham coupling. Now the basic and simplest form of the coupling is your muff coupling, which is shown as simplest form of the coupling. It is also known as by the second name sleeve coupling, which is generally made up of the mild steel. Now dear, I have a diagram here. I have the two different shafts. Shaft number 1, shaft number 2, having the both diameter is small d. Now we are using here the one key. As in the previous lecture we had discussed about the key. It is going to give you the assembling between the hub and the shaft. We are using here the key. Now the muff is inserted, muff is drawn on this periphery. What happened? The L is indicate the length of the sleeve or the length of the muff, and the D, the capital D is your consider as the diameter of the sleeve or the diameter of the muff. We have the small d here, small d is your diameter of the shaft. We have some consideration here. Tau S is the shear stress for the sleeve. Sleeve is another name of the muff, where the tau, if you're going for the bellow portion, is the shear stress for the shaft. Small d is the diameter of the shaft. Capital D is the outer diameter of the diameter of the sleeve. It's having the empirical relation with the small d. What is that? That capital D is always 2 times of d plus 13. The D is your diameter of the shaft. If you are going for the L, L is the length of the sleeve, that is your 3.5 time of small d. Means everything is depend on the design of the shaft and the configuration or dimension of the shaft. Now the P is the power capacity in the kilowatt and number of RPM of the shaft. T is the torque to be transmitted by the, from which we are going to be transmitted torque by the mean of coupling. So the T is the torque to be transmitted by the coupling, and tau is the shear stress for the shaft, as we had already discussed. Now we are going to be start the design consideration. For the design procedure, we have the step number 1, because first of all for the coupling we have to be designed for the shaft. Design for the shaft already made by us, but here we are going to a small brief that the P, the power is equal to 2 pi Nt upon 60,000 in the kilowatt, and we know that the T is equal to pi by 16 d cube into tau, and tau is for the shaft. So from this equation, two equation, we are going to find out the small d. Once the d will become, we have the empirical relation for the capital D, we have the empirical relation for the capital L2. So the step number 2 is the design of the sleeve. The sleeve is the second name of the muff, as we discussed. So sleeve is already designed as the hollow part, because we are going to insert the shaft within it. So my dear friend, for the hollow, the T is going to be changed pi by 16 tau s. Why tau s? Because we are going for taking as for the sleeve tau s d4 minus small d4 upon small d, and from here the tau s will be calculated. Now our design is going to be safe or not, you have to check it tau s from the given value in the question. If the or tau s is greater than the given value or given value of the tau s, then the design is going to be failed, because stress is so high, and if the stress is high, the failure chances will be maximum. But for the safe purpose, tau s, the or tau s should be less than the given tau s. Now for the step number 3, which is your design of key. As my friend, we have going to be join a two shaft. The sleeve should be there, and the key is going to be distribute half of both. Means if L is the length of the key in each shaft and L is the sleeve of the length, means that their relation should be small l should be equal to L by 2. As we have studied about the design of key in our previous lectures, where it is going to be checked for the two types, for the shear stress, for the crushing stress. For the shear stress, the torque should be equal to W into L into D by 2 into tau K. What is tau K? My different tau K is your shear stress induced in the key. We have to check here for the tau k whether the value should be less than to the given value or not. If it is a less than to the given value, it means the design is safe for this consideration. Now for the second, for the crushing stress, T equal to T by 2 into L into D by 2 into sigma CR into K. Again here we have to go and check for the sigma CR whether the value is less than to the given value or not for the safety purpose. Now whatever the L we have find here, we have to put here L and L. The value of the W and the value of the thickness for the square is always your D by 4. So dear, these all are the design consideration for the coupling. Thank you very much.